Hello. So if, speaker voice, hold on. There we go. That should be better. Okay, so if you are viewing this, it is because I am absent, and I'm sure you are absolutely distressed about that. Um, Me too. Anyway, my goal for today is for us to recap the things that you've been going over on pages 406 through 409, mostly dealing with observations and inferences. And then within that, what types of observations are qualitative and what types of observations are quantitative. Let's get started. You do have a Google form that accompanies this, and I will be letting you know when it's time to pause and go and answer one of those questions on your Google form. Okay? Okay, let's do it. So, this starts us out with an important question, and even the heading for this lesson is the skills of science. And that seems, it seems strange. Like when we think about science skills, usually we're thinking just immediately of like, can you hold a test tube? Do you know not to touch something that's hot? How to use a striker, how to use all kinds of things. But there's more to it than that. There's a whole set of mental skills that goes along with scientific reasoning and applying the scientific method IRL. So let's go kind of first take a little look at the idea of observing versus inference. Okay. So making an observation, your observation is not always going to be accurate. Your observation is not always going to explain what's going on. Your observation is just, it's all and only what you are perceiving with your senses. You can make observations about how things smell, how things look, how things act. You can make an observation using just your senses, feeling things, da 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 da. You can make observations from written things as well, but it's a little trickier. You can observe bad grammar. You can't observe what state of mind someone was in when they wrote something. So observations, as far as how they're defined, I want to make sure I'm doing that. Yeah, it literally says you're using one or more of your senses to gather information. It does say this is the most important science skill, and that's true. If we're not making observations, if we're not kind of being curious about our world and making observations, noticing things like, wow, that rain cloud is a very strange color, or, I don't think that's the way a raccoon is supposed to look. Oh, that's actually a bear. That second part would be more of an inference. But anyway, if we're not actually making observations about the world around us, we're not being good, curious people, and we would never notice that there are problems that need to be solved. Observation is the first step in identifying a problem that needs to be solved. And then identifying problems that need to be solved, that's the first step in science. So, yay for observation. Being an observant person in general is I think a skill that a lot of us need to work on, and one that will get us a little further in life. So let's think about observation for a minute. A lot of people so far from what I've seen have put down things like her behavior in class was terrible, so she got sent to the office as an observation. Noticing someone's behavior is terrible, that is an observation. That second part gets us more into inference. An observation is just what you notice. You haven't made any judgment on it yet. You're just observing it. You're just noticing it. You are taking note of what is there and then moving on. I'm going to let you pause right now and answer that first question about what an observation is and where maybe you had some misconceptions. So moving on to the types of observations that we have. One is called qualitative and one is called quantitative. These words have roots within them. Inside of quantitative, you see the same root that is in the word quantity. If we're talking about a quantity of something, we're talking about how many we have. It's going to have a mathematical value, a numerical value, and similarly, quantitative data is going to be data that can be measured by numbers. So things like percentages of something that we see, the number of something that we see, the number of something that we eat or interact with somehow. These sorts of observations that we can measure in numbers, we can find percentages for, we can count. Those are all going to be considered quantitative. And if you think back to that word quantity as being the number of something that you have, you should be able to remember if it involves a number, it's probably going to be quantitative. So examples, and I'm looking again to see what the book definition tells you. It does say observations can be either quantitative or qualitative. And it shows you a coral reef. Some of the examples it gives are measurements. Yesterday you worked on a paper that had to deal with apples. Like I made the whole thing about apples, and they had been, I don't know, taken over by a fungus. And I asked you for what kinds of information you would need to be able to get quantitative data about an apple. So thinking about measurements, if we had the weight, the height, the width, the girth, which is how far around an apple is, the circumference of an apple. All of those things would give us quantitative data. If we're talking about the percent of an apple orchard that's infected with a fungus, or the size comparison, and we're given numerical data, that would all be quantitative. In your book on page 407, it asks for quantitative data about organisms in a coral reef. So, a good example there would be over 70% of the organisms found are producers. Over 40% of the organisms found are endangered. In a 12 meter by 12 meter, so 144 square meter area, we found X number of whatever kind of fish. Let's go with grouper. I love grouper. It's delicious, and they are very nice if you're diving. They're friendly and curious fish, which makes me feel bad about eating them later, but not too bad. So again, quantitative, it's just going to be having to do with numbers. If I say within 144 square meters, approximately 3 to 4 large grouper can be supported, that's quantitative data rooted in numbers. It also asks you to provide qualitative data. I ask you on the Apple worksheet to provide some qualitative data. Things like the apple is red, the apple is green, the apple is juicy, the apple is sweet or tart or mealy, which is when you have that apple that just kind of has a weird, like, kind of gritty texture. The apple is crisp. Whatever you want there to insert your adjectives about apples. Those are all things that we can't measure by numbers, right? And the word qualitative in and of itself, it's like the word quality. So we're describing the qualities of something. So looking at this, qualitative data for a coral reef might be something like the colors of the reef were extremely vibrant, but compared to a few years ago, they are less vibrant now. Within a coral reef, we see a large variety of organisms. Things like this. I'm trying to think of other ways to phrase this. It's much harder when I'm talking to a camera than to people. Noticing that many of the fish have very bright colors that indicate they are toxic to predators. That would be qualitative. We're talking about the qualities things have. So if you think about those words in terms of having quantity being a number involved in one, quality being like something about it in the other, that should help you to remember which type of observation is which type of data is which. I'm going to pause here, have you pause here, and discuss your misconceptions and record any questions that you still have about differentiating qualitative and quantitative data onto your Google form. Okay, so we're going to talk now about inference versus observation. Observation is just observation. We're not reading anything else into it. It's just what we pick up on with our senses. My finger is salty. I don't know why. I just thought it was a good idea to touch my finger to my mouth. That is probably why I'm absent. I just infected myself with who knows what kind of pathogen. Something is salty, something is sweet, something is soft, something is fluffy. The sky is gray, the sky is blue. These are all observations that we're making about things. There are 500 apple trees. We're just taking that information as it is, with no judgment, no thought about what it might imply, nothing. It's just an observation. You don't take it that step further. When you take it a step further, that's when you get into inference and judgment on things. And I don't mean judgment in the sense of like, oh my gosh, she's so judgmental. I mean judgment in the sense of assessing something. So an observation, I can look around the room and observe my classroom is empty. My classroom is pretty comfortable temperature-wise. Those are examples of observations. And we have observations about all kinds of things. Being able to observe shows curiosity, and being able to observe and take note of those observations, that is the first step in science. And since it's the first step, it kind of has to be the most important step. Inferences, on the other hand, inferences are when we take our observations and then go, blah, 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 blah. So I think this is going to happen. We are making not exactly predictions, although predictions and classifications are a big part of inference. I think they kind of all go together in a little net of scientific reasoning. Inferences, according to your book, it literally says you're inferring or making an inference. That's not really helping. It's not the same as just guessing. It's that you're taking something that you already know and reasoning out something else based on that. So, for example, going back to the page about apples, I have a bunch of stuff about apples and fungus, and you can read through that. So an observation would just be something like, these apples have gray scaly patches on them. These apples are withered. These apple trees are bent and fragile. That's that. These apple trees appear to have fungus. An inference would be something like, I think that because I see these gray scaly patches across the apples, I can infer that they're infected with something like a fungus that is making them sick. The fungus on these appears to be causing apples to have less volume and trees to be unhealthy. That's making an inference. Student A comes in a bad mood and turns in work to me that is not great, and I look and I go, okay, I can make an inference that something is going on in this person's life that is causing them to just not particularly care about science today. Inferences we make all the time. It's sort of how we get through life. We take pieces of information that we know and kind of fill in what we think is going to be in the blank. Looking again, we're looking at this picture of a damselfish here on page 408. And it says, write one observation about the damselfish. I could write, the damselfish is orange. The damselfish is underwater. The damselfish has fins. All of those things are observations. Based on your observations, write one inference. Okay, because the damselfish has fins and is underwater, I infer it's a marine organism. Okay, that's a very simple one. because I observe the damselfish poking around sea urchins, I infer that it has some kind of immunity to the sting of sea urchins. Those are all things that would be kind of things. Or I'm sorry, those are all things that would be good examples. What sources might you use to research your inference? Well, if you have an inference, you can go to somebody who has more information on the subject. So another scientist, a textbook, a book written about that particular object, the internet, ever heard of it? All of those things would be places you could do research. So I'm going to pause here and let you talk about the difference in inference, and observation. Okay, finally, making predictions. When we are predicting, we are taking our inferences a little bit further. If I have inferred that the damselfish is somehow immune to sea urchin stings, I can predict that if I add a lot of sea urchins to an aquarium that contains a damselfish, the damselfish will not be harmed. Making a prediction is saying, here's what I think will happen if I do this. Or here's what I think is going to happen as a result of these things that I've observed and then made inferences about. So predicting is we think of it as like, ooh, predicting the future, or predicting weather, which we've been, we've studied. So predicting is making an educated inference, taking it a step further into saying what we think is going to happen in the future. It literally says in your textbook, predicting means making a statement or a claim about what will happen in the future based on past experience or evidence. Every morning when I wake up, Ogdal comes barreling through the house sounding like a human man who weighs 300 pounds and proceeds to start with the meow, 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 meow because he wants his treats. I can make a prediction safely based off of that past evidence, based off all the times it has happened before, that if I walk out of my room in the morning, I will instantly be greeted by an orange cat who does not believe in closed doors, personal space, and who will meow a lot. Making predictions is as easy as that. And then finally, we come down to classifying, which is grouping items together in ways that they are similar. There are lots of different ways we can do this. We can group things by similar visual characteristics, by similar behaviors. Whatever the criteria is, that's what we're going to use to group things together similarly. If I group students by their love of science, that's going to be very different than if I classify students by gender, by height, by any physical characteristics. If I group students by their interests within science, I'm going to get something different and different classifications. So things can be classified multiple ways, but it's important to kind of know how you're classifying something. You are asked in your textbook to make a prediction about how what's going to happen with humpback whales doing what's called bubble netting. I don't really think you're asked a whole lot about classifying here. So that may be something that you get a little bit of on a worksheet in the future. Finish up on your Google form here. Ooh, I'm going to put it on the Google form. Finish up your Google form here. I'm going to finish up this video and enjoy the rest of your day.